It's easy top one. I don't know if I've seen it. Oh.
Okay, I'll call this work session to order of the Seward City Council. It's 6 p.m. and it's February 12th. And the item on the agenda is the Lowell Canyon Tunnel and presentation on that. So
Yeah.
I'll turn it over to administration.
Thank you, Madam Mayor, and I will turn it over to our guest from the Army Corps of Engineers who came down from Anchorage today to talk with us about the project.
Thank you, everybody. My name is Carly Lynch. I'm the project manager for the Wolf Creek Diversion Project. And
Coleman Jalp, I'm the lead engineer for the project.
you have a short presentation. Discussion is welcome. We'll roll through the slides here, and then if you have questions as we go, we can talk about them then or at the end, whatever is best for everyone. So as many of you are aware, this is the Lowell Creek Flood Diversion Project. So we were authorized back in WRDA 2007. We did a feasibility study, and then now we're currently in pre-construction engineering and design for the project. So for today's presentation, we just want to provide an update for you guys to the City of Seward on our progression so far in the pre-construction engineering and design phase. We'll briefly look at the team organization so you can understand kind of the Corps' approach to this design. We'll talk about our Change Control Board, or I'll reference it as CCB. You know, the Corps loves acronyms. I'm going to try not to give you alphabet soup here, but Change Control Board update, the project design maturity. We'll look at some of the current design features for the inlet, the tunnel, and the outfall, and then the design and construction schedule and questions. But as I said, I welcome discussion as it comes up. So currently the design approach for this project, I think a lot of teams are switching this way after COVID, being able to draw from expertise all over the nation. But for this one specifically, the Alaska District is handling the project management, the cost engineering. We have our engineering lead, which is Coleman here, and then our contracting division are handling those pieces of the project. And then we've got the Omaha District out of the Dam Safety Production Center that is doing the design of the inlet and the outfall. And then they're working with the USBR, or US Bureau of Regulation, hydraulics lab for the physical modeling of the project for the hydraulics. And then the team for the Risk Management Center is doing the actual tunneling design. And we're also engaging with experts from Mud Mountain down in Seattle, Washington. That is a sediment bypass tunnel. And then we've got a sediment bypass tunnel in Pfaffensprung, Switzerland, that we're also engaging with those engineers. They have granite blocks as the liner for that tunnel, and they've had it installed for about 15 years. So we're actually trying to plan a visit with them to be able to understand the granite. They've got some test sections next to concrete, and so our abrasion experts are working really closely with them. So Change Control Board update. USAID's policy requires that a certified cost estimate be done every 2 years. And so our last estimate was done in April of 2021. This was coming out of feasibility with that level of design going into that cost estimate. We hit our 35% design milestone in March of 2023. Subsequent to that, we did a value engineering study looking at all the components that were going into this design and seeing if there was any areas that we could refine for cost or for engineering purposes, basically having outside input of what was going into that design. And so that drove a few of the changes in the actual design, and progressed to kind of going down a different path than we were in March. And the biggest change was the outfall. In March had a large embankment surrounding the actual flume structure, and now it's back to more of the feasibility level design of just the flume being freestanding by itself. And we've got images and stuff that we'll get into in the actual design pictures in just a few slides. So going down that path for design, we had our engineers and design team put the pencils down in September, and we went to what they call a cost schedule risk analysis meeting. And Doug got to participate in that meeting, got a little bit of a under the hood look at what goes into a design project like that, and really talked through all the cost schedule risk items associated with this project, and just really kind of hammered them out and looked at what we need to be keeping in mind for this project. And so that led to a new certified cost in December, which, because of the cost increase, triggered this change control work. So through December and January, we've had multiple meetings with our district and division leadership, as well as our headquarters leadership. And we were supposed to have our final meeting last Wednesday, which was going to be perfect timing for coming to this. So I can tell you an update of how it went and where we landed. Unfortunately, due to some other schedule conflicts, they pushed out to next Wednesday. So we will follow up with how that goes. We don't foresee any big red flags, but just normal part of the process, and we'll move forward with that meeting next week. And ultimately, the main thing to remember here is we don't have to go back to Congress for any authorization for this project. We don't need additional authorization in the law itself. We are authorized to construct the flood diversion project. Do you have anything to add here?
Part of that cost triggering was nearly double, so it gives you an idea of the magnitude of changes. And I'll get more into the engineering about the outfall, because I know that's a high topic that he's talking about, so I'll get into that side.
The engineering, the seismic was a big player, and then material and inflation, as well as contingency on the project. So, design maturity. So we're at 45% overall for the design maturity of the project right now. We've completed the phase 1 geotech investigation, which was a few select borings at the inlet area and the outlet area. We've done site surveys, the topography, like I said, the design milestone back in April or March of 2023. The bathymetry for the area, which I thought was really interesting. Photogrammetry and adit mapping. For those that aren't aware, there are several old adits in Bear Mountain that our geologists were able to go in and map to really get a better idea of the geology. And they were super interested in those, and they did photogrammetry at the inlet and the outfall. And then PSHA is the
Site-specific hazard assessment, so it looks at the seismic characteristics of the site.
Which I don't think I included the seismic in this design slides, but and then coming up and underway, we've got phase 2 of geotech investigation. So this is just a more in-depth investigation to the geotech at the inlet and the outfall, as well as some borings into the mountain itself. We've got the H&H, or the hydraulic analysis and modeling, the physical modeling, the seismic modeling, industry days. So those are where we,
So at the industry days, we'll reach out to as many contractors as we possibly can to try to get their input into how they would construct or build the project. And so we get that expertise from the contractor side for how they can build it. They might say, this is going to be extremely difficult to build. You need to change this certain way, or you need to find something like this. One of the issues with the site is that we're just very, very constrained. There isn't a lot of area to actually lay down all the equipment, all the materials, and then build the structures, build the facilities. So how do we do that? They might have some good ideas. I know in feasibility, we originally thought that we could have it up there just downstream of the existing dam. As we got more into it, avalanches came up. I know that it was 2017, 2018, the last time we did a repair. There was a large avalanche that came down just downstream of the existing dam. I think I was told, I've been trying to find pictures, but like 30 feet of snow right there. So that kind of eliminates an overwinter staging area there. So we've talked to Doug about what other areas the city can provide for staging And that helps, but then it also has distance to travel, which increases costs. So hopefully that helps a little bit with that.
Yeah. So plan to go to industry, have those conversations. There would be a set of questions that we would provide in advance. Would walk through with all the contractors that come to those meetings and have one-on-ones. That's usually how that format is. And we're planning on doing that, the first one, either this spring or summer, and we'll actually do it here in Seward likely. We may also have some in Anchorage, but we're going to try to have it here because we all know that there's a huge benefit to actually seeing the site and understanding the complexities as well as the restrictions that a contractor would have in constructing all the features of this project. And so then lastly there for PED, we've got 65 design headed in March of 2025. I'm a visual person, so we've got this little arrow going here. Well, the tiny little arrow guy is kind of where we are. We're headed into the geotech phase 2. Physical modeling will happen this summer with USBR, and then the seismic modeling as well. And then that pushes us out to actually having 95% design in September of 25, being 100% design in February of 26. And then the contract acquisition happening over 2026, planning to award a contract in November of 26 and then starting construction. And we're looking at a 5 to 6 year construction period right now for this project.
So getting to just our current design. So one of the things we mentioned a little earlier is seismic. The last time we talked about the inlet, the piles that you see there were not there. And those are there now to actually combat some of the seismic parameters that we're dealing with. When we did the PSHA, it turned out that a 9.4 magnitude earthquake is our maximum credible earthquake, and then the PGA is upwards of 2, which, knowing it's 1964, a massive earthquake that we have to design against. And the other thing that constrains our site is that the subduction zone is only 12 miles below the city of Seward. So that contribution of a seismic event is huge in our design. So those are drilled shafts. We also have those drilled shafts to the outfall, but that's added cost. But this kind of shows how you can see it coming down. The red is just velocities of the water that would be coming in at an 8,500 CFS event. We'll have wing walls that will constrain all that flow into the channel, and then it will go into the mountain, and you can see a little bit of cutting that we'll do into the bedrock, and we'll do terracing there. There'll also be an overflow weir, so if that 8,500 CFS is exceeded, whether there's debris in the tunnel or we have a surge release from a landslide upstream, we then go over that spillway or weir section into the old tunnel, so we have added capacity above just what our probable maximum flood is. On the left training wall, we're going to have a bypass structure. The picture in the bottom middle kind of shows an image of that. There'll be stop logs or some sort of a gate structure that when maintenance needs to occur, we can put a dike across the channel, divert the flow through that, remove those stop logs, and then there'll be no flow going through the new tunnel. It'll be going through the existing tunnel, and then we don't have to worry about that 2-month window of doing maintenance. We can actually go year round. So that should save on costs to do maintenance when it needs to, when the need arises. Going into the next slide, just looking at the inlet channel, you can get an idea of what those channels look like, the height of them. Currently, right now, we're looking at a long curve or a short curve. Part of that analysis is making sure that we're reducing as much of the abrasion as we possibly can in the tunnel. So in the existing tunnel, we see how the water comes in, it starts to erode the left side of the tunnel, and bounces over to the right side, causes a lot of gouging, and then it gets past the liner, gets into the bedrock, and continues to ball mill and erode everything, and that's where a lot of our major rehab and repairs are happening, is right there. So we want to minimize that with our modeling, and that's what we're doing with these. So long curve, of course, it's more expensive, more concrete, more things to construct it, whereas a short curve has less of that, and so it should reduce costs. But we're really focusing on making sure that we're reducing as much maintenance as we possibly can with the flow as it comes in. So that just kind of gives you a couple of the features. On the bottom left, you can see that there is going to be some excavation into the bedrock of Bear Mountain. Part of that is that the original tunnel took the absolute best rock there, and so we're having to deal with what's left. And there's highly fractured rock, so if you go up in the canyon right now and you go across the creek, there's a little pad where we did some investigations already. You can look at that rock and just see how fractured it is. It isn't the competent gray wacky that's all around. You can see at the outfall. Because of that, it requires a lot more excavation going back, which is another added cost. So we're looking at minimizing that. We can look at having ring steel at the entrance portal to minimize that, but our initial calcs and everything is worst case scenario, and so you can see the idea of what it is right here. Going into the current design for the outlet, the last time we came down and briefed the city, we had an embankment here. We thought that the outfall could sit on top of that embankment and be able to support all the flume. But as we got into design, it actually turned out that we had to build the drilled shafts, and it wouldn't even rest on the embankment. The embankment was pretty much just a facade to sit there. And so we knew the costs were increasing, and so that led us to actually having to remove that. But as you can see in the lower left-hand corner, we have a closed outfall, and so things will be bouncing out of there, coming out into the road. The picture in the bottom middle is 8,500 CFS. So look at that as the most amount of water that could possibly come down, and that's how far it would shoot out. Typically, you'll be seeing what we see at the existing tunnel, that the water's just coming out and falling right down. And that's we have usually, based on the gauge, 250. The recent events have gone up to around 450 CFS. So when the city is going out there and having to remove some of the material and everything's around 400. And we see that, I want to say, Doug probably knows better than me, but around 300 CFS is when it really starts to get turbulent and dirty and the material starts coming down.
We're out there about that tonight. We were watching to see what comes.
So the drilled shafts will be going down, going over the road, and then you can kind of see the pinkish color in the bottom left-hand image. That's a berm. We're looking at having large rock in there as a plunge pool, and then there'll be fences and signs saying, you know, watch out for falling rocks or anything like that, so that prevent people from going underneath there. So that kind of gives you an idea of what the outfall is currently being designed. That also, contributions of that the seismic part of it is that if we were building anything like an embankment or anything like that, we have to do ground improvements. So that's bifurcation or deep dynamic compaction, so you remove the material and then drop a huge weight on top of it, condense the soil, and then put more on top of it again. Or you can put sheet pile to start it, try to keep that preventing the material from sliding into the Resurrection Bay. So a lot of those things start to get very expensive when we start to do that. Just some of the concepts at the inlet, this terracing. Originally in the feasibility study, the lower right-hand canopy was envisioned to be able to prevent any sort of landslide from above the tunnel coming down and blocking the tunnel. When we got into the design of that, it was going to be a very, very robust structure to be able to resist any sort of landslide that would come down above it. And then the added issue with that is that we'd have to have a foundation that could support that kind of structure with the forces of the landslide coming down on it. Our structural engineers were having a hard time trying to get something designed that wasn't just an absolutely massive structure. And so during our value engineering study, this idea of terracing, so we'd have terracing that would go above the tunnel and then it'd be sloped away from the inlet, so that any landslide that did come down would direct the material away. We're also looking at putting rock anchors and netting, so when you come down the Seward Highway and you look on the mountainside right there, we have all that netting. It would be the same sort of concept right there above this to help prevent any sort of landslide blocking the tunnel. So I talked a little bit earlier about laydown staging areas. Currently, these are our areas. So we have the project site. It's been expressed that the Alaska Railroad would love as much material as we possibly can give them. So that is a potential right there, because there will be a lot of material that comes out of the tunnel as we excavate and everything. Other areas for staging, so the contractor's going to need some area to have all their materials and their offices and that kind of stuff. So that one potential area is the snow removal area. We need to look at that more. My concern is that in the wintertime, they'd have their equipment, their stuff there, and then where would the city put their snow? So that really leaves us a lay-down staging area across Resurrection Bay. And so that's what we're looking at right now. So with that, they just repaved Highway 1. And so we have to repave Highway 1, most likely due to damage of trucking, because there's gonna be thousands of trucks potentially moving and everything. And then I'd have to probably repave all the way over to that side of the bay. So that's another added cost to the project. It just starts getting added on and added on and added on. It's also a 10-mile one-way trip, and so production and productivity of having to go, if you forget one little thing over on the other side, have to drive all the way over, grab it, come back. So all these things are adding into increased costs. And so as engineering, we're gonna we gotta optimize those costs as best as we can. One thing that we're gonna definitely allow is the contractor to have some sort of barge out there. So if they can have their plant operations on a barge out there, that would help with travel time and everything, but that's also something, not all contractors have that, so how we get that, but we'd allow them to do that. And really it gets down to the means and methods of the contractor. So going on to the next slide. So this kind of goes through our construction phasing. So what to expect. This is all subject to change, but it gives an idea of what we're envisioning as the process goes on. So initially, we're gonna have a bypass road. We'd like this road to get as far out into the tidal zone as we possibly can. Now there's slope stability concerns, so this might be very optimistic as for how far it can go out, but we're gonna have that go out as far as we can, but because it's in the tidal zone, it's gonna require rock to be able to mitigate any sort of wave erosion or anything like that. And that rock can be reused at the plunge pool, so we're optimizing there. Coming in next, we'll have to construct a ramp, and that's part of the reason for the bypass road, is we need to have access up. It's about 40 to 70 feet above the roadway is where the outlet's coming out. So we have to have some sort of ramp or access to get up there. But at the same time, up in the upstream where the inlet is, we need to start constructing the bypass structure. So once we have that bypass structure in place, or as it's being constructed, we can start constructing the tunnel from the downstream end. Part of that is that it's sloped from the inlet to the outfall downward, and any water that's coming into the bedrock through cracks and crevices will be able to drain out. So you wouldn't want to start at the upstream side, have all the water coming into the tunnel, and that's just going to fill up with water and have to pump it out. So as we're starting that, the tunnel's coming from the downstream side to the upstream side. We would redirect Lowell Creek into that bypass structure so the water would start going through there and allow us to get some excavation in that area. So you can see how the flow of the water would then be bypassed this way. Due to the creek, water table is about 5 feet below the ground surface in most of the area. And so we have to have dewatering wells in the area to pump the water out so we can excavate, because the inlet is about 30 feet below the existing ground surface. So we have to have an excavation that deep. To add to that, it's very constrained. We have that scale, it's about 225 feet. And so when you start to think about your slopes, setbacks for a 30-foot excavation, those take up a lot of room. And so we're looking at having soldier piling to be able to do that sort of construction, but we're very limited on the area that we can use. So this is just showing that excavation that would occur in that area with the dewatering. The new tunnel would then exit at the inlet area, and then we can start to construct the outfall with the drilled shafts, and then construct the rest of the concrete that would be at the inlet and the outfall area. Once that's done, before that's done, we also have this shaded area on the right-hand side of the inlet would be for excess material. So we put that behind there. It doesn't have to go there, but we're just thinking that keeping it there and not having just a concrete wall right there, so it'll protect it some. We would then remove the bypass road, place that rock that was there at the outfall for the plunge pool, so we're not having excessive erosion that would occur just through normal flows. And that would also be able to redirect traffic then underneath the outfall. And then we remove that bypass or the dike that goes across the inlet channel, allow flow to then return, or not return, but go through the new tunnel, and our project will be done. So if we have maintenance, we just put that dike back in place, open the stop logs, and then we can redirect flow, do any sort of maintenance on the inlet area, the tunnel, and should minimize costs. We're not restricted to that 2-month window. That does add a lot of costs because the contract doesn't work fast. Another issue with that is any high-strength concrete. We're moving it really fast, it's not having time to set up, so then it has flow going over it. There's a vent right after that, then it's destroying it quicker because it doesn't have the strength that it needs to develop. And so overall, it'll be beneficial for the project having this bypass structure and the two for maintenance. And then the very last thing that we're looking at doing is doing maintenance on the existing tunnel, so it's in all good working order. Any defects or anything that's there, because we're looking at another, 10 years before everything's all done from right now. I think 24, we're until 26, so 8 years. But in that time, we typically see about every 10 years having to do maintenance on the tunnel, and so we know that there's have to be maintenance before. And that's it on that. If there's any questions, or Carly, you have anything else to add?
Seems pretty simple, project.
Wow.
I know that's drinking out of a fire hose, but I know there's got to be questions, so.
Yeah. Questions, comments?
You said there'd be thousands of trucks running up and down there.
Eventually, yes.
What would the hours of that probably be? Because that's in going through a residential area.
There are probably restrictions on when we do it. The city has to when those times would be allowed. It'd most likely be during the daytime, so it wouldn't be at nighttime. But we've also looked at, like, there's going to be blasting that occurs as well. There'd probably be 2 blasts a day, and we time those to be like 8 a.m. in the morning, and then afternoon, evening, early evening kind of time frame for blasting as well. So.
In the residential area, everybody be notified of that?
Yep.
Other questions?
What is that time frame for blasting? Are you looking at a year or?
So the original construction took a year. Back then they didn't have OSHA. They didn't have all the regulations. I think a year would be optimistic, but it could be up to 2. Yeah, but we're gonna, part of the awarding the project is we're doing best value. So, the contractor has a really good idea of as to how that gives them more, not points, but more emphasis on them being able to be awarded to. This gives them a leg up. They have different ways. We build that into our contract as to this is one of the things that you need to address. And if they have good ideas, it will help.
Councilmember Calhoun?
Yeah, thank you, Madam Mayor. So have we absolutely determined that across the bay is the best place to stage everything?
No, I think we're.
Because,
well,
having tons of trucks and stuff running Nash Road
Yep.
just doesn't seem like a very good situation for, for any of us, you guys included. And
Definitely open to ideas if people have ideas. We're at that stage that we can make those changes, we can account for them. And so getting that information to us, like, hey, there's a good area here, good area over here. Have you thought about this? Sure, definitely helps with how we plan, construct the contract.
yeah, I think we're really gonna have to look at that because that would be, that's not anywhere close to optimal at all.
The good thing about us using that for now is that we've costed, quote unquote, the worst case scenario.
Yeah.
So
Right.
that 10 miles one way is included in this cost estimate. And we know there's it definitely optimized from there, right?
Councilmember Kreitz, yeah.
I was just going to ask as far as like how many people on the site for construction? Is there, like, are you estimating how many people that would bring into Seward, and then where are you going to house those people?
I don't know what the estimate for
I think
construction.
through our estimate, we looked at about 100 people. And then we also looked at having a man camp to be able to provide housing for those people. So one benefit of across the bay would be that we could construct a man camp. Similar for another one of our projects at Nome, or a Nome modification that we are also doing, there's a man camp for that, so we have some experience in writing a contract to it, that sort of thing.
But that's not necessarily the plan right now, so the contractor could decide to host their folks in a different manner.
They could bring in a cruise ship. That could be a lot of things.
You said the railroads requested a lot of the gravel and stuff. Have you approached them for staging there or man camping at the railroad, since it's a lot closer and they got a big wide area?
We have not, but that could definitely be.
If you want dirt, you have a trade. You got a trade.
She's right behind you.
Consider
Yeah,
something
she's right
like that. Yeah.
Do that.
Just an idea. I mean,
Good
why go
idea.
across the bay when you got all that railroad land?
Yep.
You know.
Yeah, but I think, I think part of it is also just real estate. How do we do that? How do we sort of agreement come into place with that?
Other questions? Councilmember Barnwell?
Probably spent all day asking questions, but I'm just curious about that. Would you call it a settling pond? When we, the outflow, where we typically, Doug's crew typically shovels out of there. And isn't that just going to fill up with debris? And it's the same thing, but it'll be deeper water. So how do we, or will it not be deeper water?
So the purpose of the outfall is to get the city workers from get them away from being out there during an event. That doesn't prevent all the material that's going to come down. There's still going to be, the turbidity, all that material coming down. But then after the event's stopped, when it's safer to go out there, then we can go out there and start moving the material, pushing it back out. The same thing that the city already does, but it prevents that risk to life safety out there. So there'd still be there, and that plunge pool would be there and shaped in a way that the rock would stay. There'd be material on top of it. When there's heavy flows and we're getting a lot of scour coming out, those rocks are protecting it from getting too big, and then moving it out after everything's all said and done. So if we have a large event, there could still be, like we saw in '86 with all that debris that came out, that is a potential if for some reason, as that's deposited, it starts to push it back. But we're also putting that berm behind it to try to help prevent that, and it's angled in a way to try to divert it and direct it out into the bay rather than towards like the shellfish hatchery in the other area.
Are you still planning on logging out in the canyon?
So there'll be select tree cutting up there. So any tree that's 48 inches in breast height would be removed, and a lot of that is, so yeah, they're big trees.
No, I mean from distance, from how far out? Like we talked within a quarter mile or even 100 yards of the tree.
It's not quite that on the upper right, but basically any trees you can see above the existing
Yeah, it's
tunnel.
not that big of an area.
Yeah.
Maybe
I don't have to build a house.
Wow.
Just enough trees to make a hole.
And really, like, when we went through the risk assessment, and what really led into the failure modes for this, it was the very large trees that could maybe get picked up during a flow, get lodged into the tunnel, and then the debris that's coming down gets stacked up behind it and blocks the tunnel. And so those are the trees that we're trying to prevent. If a landslide came down, something came down to get that tree into the channel, we're removing that potential.
That's always been one of our worst case scenarios. Yeah.
Is there gonna be anything upriver, like a big giant cage that catches the rocks? I've lived there 30 years, I've seen boulders shooting out of that thing.
We looked at that during feasibility. There's always that potential that having a stilling basin, is what we call it, having material get trapped there, but then the maintenance cost gets, instead of having to do it at the outfall, now you're gonna have to do it up there, because all that material's getting caught up there. And so the cost is actually probably gonna be more, because now you're trucking from there, instead of some material goes out actually into the bay. So.
Go ahead, Councilmember Berman.
You guys have obviously done landslide assessments up there in that canyon, because that, to me, I mean, just walking in there, it just looks like a huge opportunities for all kinds of landslides.
So we haven't actually, like, the Corps of Engineers hasn't been there, and like, this is where the landslides are gonna happen, and everything like that. But the USGS has maps for where those landslides occur, and so we use that. We also have the historical landslide that you can see in the basin, where it actually redirects the flow towards the north. And that's what we've used to look at that. But that's all we've had. We haven't actually, the Corps hasn't done any analysis of the landslides.
Administration, what do you have to ask or add?
Cool.
I know, it's kind of
I'm just
mind-boggling.
imagining like a big party when the first water comes
Right.
out in 10 years.
Oh.
May I just want to
But
make a statement, sorry. That is a huge shore fishing area, right, for snagging silvers. And so just out of curiosity, who would be responsible for keeping fishermen out of that area? Would that be the city of Seward's responsibility, or would that be the construction crew's responsibility, or the state, or the Fed?
Typically, if it's a construction site, our contractor would be required to put up fencing and keep people out of there.
Okay.
So they'd be required of that.
Good, so we wouldn't be responsible.
I'm getting nods from administration.
Yeah.
I have a quick
Yeah,
question.
Jason.
Do you guys know like kind of the footprint that you guys need for your laydown yard and for like a man camp? Because if you guys could kind of get us like general sizes of what you might need, we might be able to look around and help facilitate some conversations. And since we're pretty familiar with kind of just the land and who owns what around here, and that way we can give you guys some options,
So
that would be great.
That's definitely something we're looking into. So we're gonna make a site visit to Chimney Hollow. It's a dam in Denver that's being constructed with a tunnel. It's like a 30-foot tunnel low. And so we're gonna get an idea of how much required area is for that. It is a large area, but I don't have that number.
Okay. Yeah.
But we can
But-
get into that.
Yeah, once you guys do figure out something like, okay, we probably need this many acres for a laydown yard, or this many acres for man camp, just let us know and we can give you guys some options, yeah.
Councilmember Wells.
Thank you. For administration, don't we have some property that we need lots of fill for that we were just talking about? No, seriously.
yeah. Yep.
Okay,
I don't think it'll be an issue to get rid of the rock.
right.
Which is a nice plus to all of this construction.
Mhm.
So.
Okay.
Okay, anything else? No? Well, thank you for your presentation. Everybody's been asking me what's going on with it, so now they can watch this. And, yes?
One more thing to add too, they'll be here tonight and we have a lot of meetings scheduled with stakeholders throughout the community tomorrow as well. So we'll be able to answer some more in-depth
That's all been
questions.
scheduled.
Yes, and that's all been scheduled for tomorrow. So we have some fun stuff planned as well.
Perfect. Okay, anything else? All right, I'll close the work session at 6:38 by that clock, and we will